Time travel. It's been the dream of scientists, philosophers, and sci-fi fans for generations. From Bill and Ted's Excellent Adventure to Interstellar, the idea of moving through time has fascinated us. But is time travel really possible? Could we ever build a machine that lets us step into the past or see the future? In this video, we're diving into the real science behind time travel, what physics tell us, what theories exist, and whether it's something we might achieve one day. Before we can talk about time travel, we have to understand what time actually is. According to Einstein's theory of relativity, time isn't a fixed constant. It's more like a dimension, just like space. Think of time as similar to the chapters in a book. Just as you can flip to a previous or future chapter to see different parts of the story, time might work the same way in the universe, where all chapters still exist, and the idea of moving forward or backward through them is what we call time travel. However, time is intricately woven together with space, forming what physicists call spacetime. Instead of being a universal clock ticking at the same rate for everyone, time can stretch, bend, and slow down depending on speed and gravity. This concept, first described by Einstein, is the foundation for all serious discussions on time travel. In fact, experiments have proven that time is relative. In 1971, scientists flew atomic clocks on commercial airliners and compared them with synchronized clocks on the ground. The clocks in flight ticked slightly slower, just as Einstein predicted. This was a real-world confirmation that time doesn't pass at the same rate for everyone, an essential principle for considering time travel as a physical possibility. Now, let's talk about one way we know time travel is possible, at least in one direction. Time dilation is a proven effect of Einstein's theory. The faster you move, the slower time passes for you compared to someone at rest. For example, let's say an astronaut travels on a spaceship moving at 90% of the speed of light. If they spent 10 years traveling at that speed and then returned to Earth, they might find that 50 years have passed for everyone else. So essentially, they've traveled into the future. Another way time dilation occurs is through gravity. The stronger the gravitational pull, the slower time moves. Scientists have measured this effect on Earth. Atomic clocks placed at different elevations tick at slightly different speeds. This means that people living on mountains age slightly faster than those at sea level. This effect is also crucial for GPS satellites, which need to correct for time dilation to provide accurate navigation. There's also the famous example of cosmonaut Sergei Avdeyev, who spent a total of 747 days in orbit aboard space stations Mir and the International Space Station. Due to time dilation, he aged about 0.02 seconds less than people on Earth. While that's a tiny difference, it's real. This proves that time travel to the future is already happening, just on a very small scale. With faster speeds or stronger gravity, the effects could be far more dramatic. So if we can travel forward in time, what about going backward? This is where things get complicated. While the laws of physics don't strictly forbid traveling to the past, they impose major challenges. One idea involves closed time-like curves, a theoretical concept where spacetime bends back on itself, creating a loop. Some physicists believe that if a massive object like a spinning black hole twists spacetime strongly enough, it could create a path that leads backward in time. However, there are problems with this. First, the energy required would be astronomical. Second, the slightest disturbance could disrupt the loop, making it unstable. And lastly, there's the question of whether information or matter could actually survive the trip. Would it be like stepping through a doorway, or would anything attempting to time travel be destroyed in the process? You should look up spaghettification. A related idea comes from a solution to Einstein's equations known as the Tipler cylinder, a hypothetical, infinitely long cylinder spinning at near light speed. The rotation could theoretically twist spacetime enough to allow for time loops, but the concept remains highly theoretical, and an infinite cylinder isn't exactly something we can build, at least not yet. Still, it shows how deeply time travel is embedded in the possibilities allowed by general relativity, even if those possibilities remain wildly impractical for now. Another popular time travel concept is the wormhole. You've probably heard of this one before. Imagine spacetime as a sheet of paper. If you wanted to travel from one end to the other, you could move straight across. But what if you folded the paper so that the 2 points touched? That's the idea behind a wormhole. A shortcut through spacetime that could, in theory, allow for instantaneous travel between 2 locations in space and time. I really recommend watching Interstellar if you haven't yet. But there's a big issue with this. Wormholes, if they exist, would be incredibly unstable. The moment anything tries to pass through, they could collapse. Some theories suggest that exotic matter, a type of material with negative energy, could hold them open. But so far, we haven't discovered anything like it. And even if we did, would it be enough to stabilize a wormhole for human travel? Scientists are still actively searching for answers, and hopefully we figure something out in my lifespan because that would be pretty cool. Interestingly, in 1988, physicists Kip Thorne and Michael Morris proposed that if a wormhole's 2 ends were moved relative to each other at high speeds and then brought back together, they could function as a time machine. This idea became a major inspiration for science fiction and was based on real mathematics. However, the need for exotic matter, something not yet proven to exist, makes this concept a bit speculative. It's a captivating idea, but for now it remains in the realm of theoretical physics. So even if time travel to the past were possible, it introduces paradoxes. The most famous is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you would never be born. So how could you have gone back in time in the first place? One way physicists try to resolve this is with the self-consistency principle, which suggests that the universe prevents paradoxes from occurring. This means that if you traveled back in time, you could never change events in a way that contradicts the present. Another idea is the many worlds interpretation, where every action creates a new timeline. In this case, you could go back and alter events, but instead of changing your own past, you would create a parallel universe where the new history plays out. Cough, cough, Avengers. In 2020, physicists at the University of Queensland developed a mathematical model showing that particles could theoretically travel through time in a way that avoids paradoxes. Their simulation showed that events could self-adjust to remain consistent. For example, even if you tried to stop the spread of a disease in the past, events would realign so the outcome is preserved. While this is still highly theoretical, this lends some support to the idea that time travel might not violate logic, if the universe behaves more like a self-correcting system. So, will time travel ever become a reality? I don't know, man. But right now, it remains purely theoretical. While we know that traveling into the future is possible through time dilation, traveling to the past is still highly uncertain. Some scientists are exploring whether quantum mechanics might hold the key. Quantum entanglement, where particles instantaneously affect each other regardless of distance, suggests that time and space may not be as rigid as we think. Could future breakthroughs allow us to manipulate time in ways we can't yet imagine? If we ever crack the code of space-time, it could revolutionize everything from space exploration to how we understand reality itself. Another area of interest is quantum gravity, the theory that attempts to merge general relativity and quantum mechanics. Some approaches, like loop quantum gravity and string theory, hint that time might be an emergent property, not a fundamental one. If time is something that arises from deeper laws of the universe, then manipulating it might be more feasible than we think. But until these theories are tested and confirmed, the dream of time travel remains just that, a dream. Still, our understanding of the universe is evolving every day, and what seems impossible now might someday become reality. Time travel remains one of the most fascinating concepts in science. While we may never build a machine like in Back to the Future, the laws of physics suggest that time might be more flexible than we ever imagined. The future of time travel will rely on advancements in our understanding of relativity, quantum physics, and perhaps even new theories that don't exist yet. Whether or not we ever achieve true time travel, the quest to understand time itself will continue to push the boundaries of human knowledge. So, what do you think? Will humans ever conquer time itself? Let me know your thoughts in the comments. And if you enjoyed this journey into the mysteries of time travel, don't forget to like, subscribe, and hit that notification bell so you don't miss our next deep dive into the universe. Thanks for watching, and stay curious.